Weather. Lots of possible ways. How about you guess what the weather is going to be tomorrow? Well, it's kind of warm and sunny out there now. That's one possibility, the persistence method, assuming that the current weather is going to be what we see next. What's the weather today? That's basically a question that the persistence method asks. It's a bit like the joke you can buy as a gag gift, Weather Rock. It will tell you what the weather is. Look out the window at the rock. Is the rock wet? It's raining. Is it covered in white? It's snowing. Is it flying around in circles? It's a tornado. Yeah. Not all that helpful there. When could this work? Well, we noted weather is going to tend to be the same for a while if we're under an air mass. So, yeah, there are plenty of times when one day is pretty similar to the previous day. If the weather's not changing, yeah, persistence works. Also, long-term average, climate changes much less than the weather. So, as you get too far into the future, calculations get too much of a mess, and we can't predict precisely, say, how hot it's going to be 3 weeks from today. Now, we've got a guess 3 weeks from today. That's, let's see, today's 7/20, that's the end of April. So it's probably going to be in Boiling Springs a warm spring day. But how warm? And we'll have to wait a bit. But we can kind of guess, okay? What's the weather been like so far? Is the spring warmer than usual, cooler than usual? That might be a little better than just it's spring. It's also useful as kind of a default. For example, can my model predict the strength of a tropical cyclone for 5 days in advance? Well, let's say I'm guessing it's just going to stay the same as it is now. And then this model, what does it predict? Okay, which does a better prediction? Saying it would just stay the same, or the model? If the model does better, okay, that's good. If the model is no better than just saying, well, it'll stay the same, then the model's not really helping us. Climatology. We can use this somewhat more long term. What do we think the weather will be like in Boiling Springs, August 25th of 2021? It's August. It's going to be hot and humid. That's what it pretty much always is this part of the world. So look at the long-term average. What's it been like August 25th in the past? Now, of course, if something weird happens August 25th of that year, then our prediction's going to be wrong. But it's probably reasonably close, especially if we have a lot of records to look back on informing our prediction. Trends method. Not just what is it today, but look a little more widely for any particular patterns. Do we have fronts? If so, what are they doing? What are the patterns in highs and lows? Clouds, is it getting cloudier? Is it getting clearer? Precipitation, how are things changing? Okay, where's that going to work? Well, obviously, if we've got a fairly steady trend, no extra complications in there. For example, on the map here, relatively short-term local features, this works well. You see map here, okay, let's say yesterday there was a cold front here. Today there's a cold front, it's moved to there. What do you think will happen tomorrow? I think probably we're going to have a cold front here. That's the general pattern. This was demonstrating when I graduated with my master's degree from Chapel Hill. Right at the beginning of the ceremony, outside in the stadium, they announced that the Weather Service had reported that there was a storm system heading in that general direction. Then they proceeded to read to us everything that was already in the program about all the honorary graduates. And the storm system followed the trend, came right there, and started dumping rain all over us, and folks flee for cover as they say, okay, you're graduated. There was a clear trend, which they did not pay attention to. Analog method will be another way that you could forecast. Okay, we've looked at what's it doing now. What's it been like on that date in the past for their climatology method? Looking for trends. Another possibility is, can you find a day where the conditions look just like what they are now? What happened next? That can be a pretty good approach. Of course, if you can find a matching day, you do have that challenge. So, again, that's going to depend on how good your records are. Can you find a matching day? And, of course, finding it fast enough. If you have to pull out a bunch of books and look it up, that's going to be kind of slow. A computer can do that a lot faster. Like our climatology model, the more records, better detail, the better this will work. And again, it can work quite well. This was what we'd used to mention that first forecast of a tornado. Well, the first good forecast of a tornado. Because weather looks just like it did a couple days ago when there was a tornado. And that's not good. Better warn people. Some other things to keep in mind. Any important weather features. Is there an anticyclone, as diagrammed here, or high pressure northern hemisphere is going out clockwise, or a cyclonic system? Other things there to look at. Fronts, cyclones. If we do have an anticyclone, that suggests we've got fair skies, no precipitation in the area of the high pressure. As a high is coming in, our part of the world, highs will generally be coming from the west. And so winds are going this way on the east side of the highs. It's coming towards us from the west, which is coming from the north. So we didn't have somewhat cooler conditions ahead of our highs. That'll be true most of the U.S., not for Hawaii, South Florida. They tend to be getting prevailing winds coming from the east, but most of the rest of the U.S. and areas in similar latitudes primarily from the west. Once that high moves past, we've got winds coming from the south, and that will give us warmer weather here in the northern hemisphere. If we have a cyclone, the rising air cools, so as it cools, reaches the dew point, makes clouds, maybe rain, if it's strong enough, storms. If, again, our low is coming in its typical way for an extratropical low, extratropical cyclonic system. Then for around here, we'll typically have warmer conditions in front of it and cooler after. Our tropical systems, however, if one of those comes along, it's got its own path, typically, actually, because the ocean's east of us, it's coming from the east. Well, it could come up from the Gulf of Mexico, come in from the south as well, but for around here, more likely that the tropical system will actually come from the east. The typical overall path of a hurricane tends to curve from east to west as it is in the more tropical regions because the winds are primarily coming out of the east, and then back towards the west as it moves into the mid-latitudes. And it's moving away from the equator as this happens. But the exact track, there can be loops and squiggles and all sorts of things at one particular part of a tropical system path.